up our long overdue player getting hit by enemies. So flash, knockback, health, and then the ability to die, and we'll eventually work our way into getting respawned. Let's dive in. Now the first thing I'd like to do is just clean up my editor just a tad. I'm going to close these 3 tabs over on the bottom right just to give my project window a little bit more wiggle room. So just like before, let's get some of the things in the skeleton set up in place for what we'll need in both the code, but first in Unity. So what are we going to need? We're going to dive into our player. And let's see, we have a player controller, we have the animations. We do need to rig up these serialized fields for our health component, and looks like that's already attached. That's great. We have knockback, don't need to rig up anything there. I think the only thing else we need to add is our flash component. So let's go ahead and add our flash class, and we can go ahead and click this lock button in the very top right, and we'll rig up some of these serialized fields. So materials, textures, we can go ahead and drag in our default material and our white flash material. Now I do think we need to create these splatter prefabs in the Death VFX. So let's navigate into assets and we'll see if we need to rig those up. So VFX, great, looks like we already have our player Death VFX. Let's go ahead and drag that into the scene. I think we need to unlock it to see what it looks like. All right, good start. I think the first thing I'd like to do is just make sure it's the same shade of orange. So clicking the start color field, the eyedropper, we'll just make sure that it's orange, and I think that's a pretty good start. Yeah, you know what, that's pretty close. I think all I'd like to do is just ramp up the start size a bit, maybe to something like 1.6, I think will be about right. Yeah, you know what, that's good enough for me. I'll go ahead and apply that to the prefab. Delete that from the hierarchy, and then we'll go ahead and drag that into the field. So player health component, and we'll drag our player death VFX into that field. But I do think we need to still create this splatter prefab, so we can come close to duplicating our enemies one. So assets, prefabs, and enemies, yep, and we can go ahead and duplicate this one. Let's call this the player splatter, and we can drag that into the player prefabs folder. Nice. And let's just drag that into the scene to see what it looks like. So I think all I need to change is actually in our sprites folder, I've got another splatter sprite called the splatter large. And that's about it. I'm going to do the exact same thing. We don't need to change the color dynamically through code. So all I'm going to do, eyedropper, and select that same sort of orange. Let's make sure those changes are applied to the prefab. Great. And we can delete that from the hierarchy. And then we can go once again into our player prefabs, make sure our player is selected, and drag that player splatter in. Nice. Next up, let's rig up our audio, and then we'll jump into the code and rig all those things up. So audio, sounds SO. We know we're going to need a player hit sound, so I'll go ahead and create that. Player hit. We'll make sure that is set to the player hit SFX. Great. I'm just going to increase my volume just a tad, not too important. And then let's also rig that up in the sounds collection. So we don't have that created yet, I don't think. Nope. Let's go ahead and open that up. And right here at the bottom, let's create a public sound SO as an array. And I'm just going to call mine player hit. And heading back into Unity, let's just rig that up. All right, let's see if we can find that right here at the bottom. Very nice. Click the plus button and find our sound SO player hit. All right, good to go. All right, and with that, I think we have everything set up. Now we have some fun game architecture decisions to make. Where do we want to put this logic? Do we want to put it on our player and basically detect when it hits an enemy? Do we want to put it on our enemy and detect when it hits the player? We have the eye damageable and the eye hittable interfaces, so where do we want to use it? Well, I think the best way to actually do this is one of the components both our player and our enemy share is the health class. So currently, on the enemy class, well, let's go ahead and open that up. I think it would make more sense if we actually just did that directly on the health class. Then we can use it for both the player and the enemy. So let's actually just get rid of these two functions entirely, both the take damage and the take hit. I'm going to actually cut it to make sure that I can paste it over on our health class. So let's open that up as well. And on our health class, here, let's actually implement the eye damageable interface. And then right here at the bottom, we can use those two public methods. Now we do need to get those components, so let's actually just go ahead and cut them out once again from the enemy. We don't need it in the enemy anymore. And I think this makes a lot more sense. So on our enemy, if we cut out the knockback, flash, and the health components, and we put them into our health class in Awake, let's go ahead and do that. So Awake, we don't have one of those yet, and we'll just copy paste those components in. With those 3 references, we have basically everything we need to get it immediately working still on our enemy. Because on our bullet, we're basically just detecting the eye-hittable interface and the eye-damageable interface. Well, it's making contact with the enemy, and then it's just looking for these 2 interfaces on the components of the enemy, basically. So it doesn't really matter, actually, from bullet to enemy if it's on our enemy class or the health class. But what this is going to allow us to do is we can now use these interfaces for the enemy hitting the player as well. But just for a little bit of a sanity check, let's head back into Unity, and with that little refactor, make sure everything is working as intended. I'm just going to go ahead and mute my sound for now. And yep, just like that, we have everything still working as intended. When the bullet is hitting the enemy, because of the way we've reworked and refactored those interfaces, everything is still working as intended. Next up, where do we want to put the enemy detection hitting our player? Well, that part, I think it actually makes sense to put it in our enemy class. Just like the bullet is hitting the enemy, I think it makes sense to put something like this in the enemy. So if we open back up our enemy class, we can just go ahead and create right below the Unity methods a on collision enter 2D. And we can just check if it's the player. So let's go ahead and grab that reference first. So player controller, we'll just call it player. And we'll just check other.gameObject.getComponent player controller. Then we can just say if it's not the player, then we'll return. And we don't need it to do anything else. But if it is the player, then we want to basically go into eye-damageable and eye-hittable and go into those interfaces and do those 2 things. So if we go into our bullet class, we pretty closely want to implement these exact same 4 lines of code. So you know what? I'm going to do that. I'm just going to copy these 4 lines of code from our bullet, and then in our enemy, we're going to do something very similar. We're just going to check, hey, if it's the player, then great. And if it is, let's use those eye-hittable and eye-damageable interfaces that we're implementing on the health class of our player. So everything actually looks pretty good so far. We just have to pass through slightly different parameters. So damage amount and knockback thrust. Let's go ahead and come up here. Let's say serialized field. And I'll just say private int, what was it? Damage amount. Great. And we'll just call it 1 for now. So 1 damage when our enemy hits our player. The other one was a serialized field, except this time I think it was a private float, and it was called knockback thrust. Let's do something a little more drastic. I think somewhere around 25F should be good. And just like that, we've implemented those 2 interfaces. Nice. I think that's a good, clean way to do it, but we do have one little issue. Before, we were getting knocked back directly from the player position, so we obviously don't want to do that anymore. So let's go ahead and actually just pass through one more parameter. I'm going to make it the first parameter, and I'm just going to pass through a vector2 for the damage source direction on basically where we want to get knocked back from. So I'll just call it damage source, and then I'll just call it damage source dir, or dir for direction. So now that we have this damage source direction, we can actually just pass that through to make sure that our get knocked back works properly. Next up, you can see we're getting a compilation error on our interface directly. It would probably make sense to do that the other way around, but I think you get where I'm going with this. On our eye-damageable, we also need to implement and finish off that contract that we have. So vector2. And to use a vector2, I think we need to use the Unity engine namespace. There we go. And let's just go ahead and call it the same thing. So damage source direction. That way we'll no longer get that compilation error in our health class, but we are getting it in both the enemy and the bullet where we're trying to use that interface. So great. All we need to do is on our bullet, finish off that contract. So what do we need to do? We need to pass through the direction we basically want to get knocked back. If I'm not mistaken, at the top here, yep, we already have a fire direction. So we can actually just plug into that directly to make sure we're getting knocked back in that same direction. Very nice. I'm liking that a lot. And last but not least, let's head into our enemy. This one's simple enough. We just need to pass through the transform.position of the enemy to make sure our player gets knocked back in the opposite direction. All right, I'm not getting any compilation errors, but I can't help but think it feels like I forgot something. Let's see how we did. Let's head back into Unity and see where we're at. All right, hitting play. Great, looks like we can still hit the player. And there we go. If our player comes in contact with the slime, we're getting knocked back properly. Now let's see, there we go. We do have one more little error. Let's go ahead and see what that is when our player basically tries to die. So let's go ahead and double click this. There we go. So our player isn't trying to change the color. Well, that's simple enough. All we need to do is just check to make sure that this Death Splatter Handler class, when it uses these two functions, that it has that color changer. So we'll just say if color changer, and if it does, well, then we want to do these two things where we're trying to manipulate the color changer. And I think we need to do the same thing in our Spawn Death VFX. Yep, looks like it. So if color changer, same thing on these two lines that we're trying to manipulate the color changer. Let's just shift those up into that if statement. And there you go. Just like that, we should have that null reference error fixed. Let's head back into Unity and try that one more time. Now, I think there should still be just one little thing that we're going to need to fix, but let's see if we can actually trigger that bug intentionally. So when we hit the slime, 1, 2, and 3. There we go. So 3 health. And we die. Okay, good. Everything is working properly. I thought my player had 3 health. It looks like it had 5. I'm just going to shift that down to 3 for testing. But there is one little bug I didn't actually trigger even though I tried. There we go. That was it. So it actually just hit twice, even though it killed us and it did 3 damage. Well, go ahead and have a think on why that might be. Well, that's because there's no sort of cooldown for when our player is getting hit. So it essentially triggered getting hit twice within really quick, short succession. So I think that leads us well into this lecture's challenge, but let me point you in the right direction. What can we use that we basically already have in place that would act like a cooldown? Well, on our player movement class, if we go ahead and give that a click, on the movement class directly, we have a can move bool. I think the best way to go about doing that is if we just expose this bool, we can just directly check if we can move and then make sure we can't get hit while we also can't move, and that'll be a kind of a natural, easy to use cooldown. So in our movement class, let's go ahead and expose that bool. All we need to do is call it public bool can move with a capital C, and then with the arrow syntax, we'll expose the can move private bool. Now all we have to do is go back into our enemy class and just make sure that our player is able to move. Now you could probably figure a way to do this out in health, but I'd like to simplify it and just only actually keep that in mind for our player, not necessarily our enemies. So in our enemy class and in this onCollision2 property, I'd like to introduce you to this lecture's challenge. In our onCollisionEnterToD method, write some additional logic using our canMove bool that we just exposed and make sure that we have a bit of a cooldown for how often our player can get hit and take damage. Go ahead and pause the video, give it an honest effort, and I'll see you back here in a few moments. All right, welcome back. The way that I'm going to do it is right below this return statement. I'm going to go into my movement class. I'll call it player movement to be explicit. And I'm just going to say player dot get component movement. Right below here, we can just check if player movement dot can move. Then we want to do these two things. Nice, and just with that set up, we have a nice little natural cooldown to make sure our player isn't going to get spammed and immediately die if it gets stuck in a corner and the like. Next up, we're almost there. Let's go into our audio manager and just rig up that last little bit of audio. So we have to ask ourselves, where do we really want to fire this method? We don't really have a player on hit action that we could subscribe to, so we have a couple different options. Because this is a relatively simple execution and we're only doing really one thing when our player gets hit outside of our interfaces, I'm just going to go ahead and plop it right here directly in my onCollision2D. Now, I don't love it, but I think I'll be okay with it and I can sleep at night. So in our enemy, we basically just want to say on player hit. And what do we want to do? We want to play that random sound just like everything else. Sound collection SO dot player hit. And because we're going to make this a public void on player hit, we can just go into our enemy directly and right here say audio manager dot instance dot enemy underscore on player hit. Now, I'm not in love with where we're firing the audio directly. You could probably take the time to create an event or something along those lines and subscribe to it to keep up with the audio manager pattern that we've been implementing. But for now, I'm pretty satisfied. Let's go ahead and try that out back in Unity, and we'll see how that sounds. All right, let's go ahead and hit play and make sure everything is working as intended. First and foremost, yep, we can go ahead and still kill the enemies as intended. And when we hit the slime, yep, I can hear the knockback audio. We're taking 3 damage. We're getting flashed. We're getting knocked back. We are set to go. All right, well done on this lecture. We're getting close to the end. When you're ready to move forward onto the last few lectures, I'll see you on the next one. This lecture, let's rig up the very top right score manager that we have, so every single time an enemy slime is destroyed, we up our kill count by 1 and display it on our UI. Let's dive in. Now, I think we can actually make the majority of this lecture a challenge, but let me actually get you started and pointed in the right direction. We're not really implementing a lot of new concepts on this one. So let's head over to our scripts. And let's just plug this in miscellaneous and let's just create a new C# script and let's just call it score. I'm going to attach this class directly to my UI game object that we've had here in the top right for the entirety of the course. And I bet you've probably been wondering what in the world are these 3 zeros for? So right here on our UI canvas, on our score text, let's just go ahead and attach this score class directly to it. And with that attached, let's go ahead and open that up in VS Code. So all I would like to do in this class is every single time an enemy dies, update that text by 1 in our UI. And you know what? That's all we're really trying to accomplish. So because we're nearing the end of this course, we're not really actually going to be implementing a whole lot of new teaching points that you don't already know. So I think now's a great opportunity to take this entire class as a challenge. So in our score class, create some logic subscribing to our enemy on death event that updates our score in our UI by 1 every single time a slime is eliminated by the player. So I think you have everything you need. Go ahead and give this your best effort. Pause the video and I'll see you back here in a few moments once you've given that your try. All right, welcome back. So what do we need to do? In our health class, we have this nicely created on death event. Now, the one thing we do need to keep in mind that we'll handle on the next lecture is we do need to keep in mind this on death event is also firing for if our player dies. So we'll get that set up in a moment. But all we need to do for now is go ahead and get that component first and foremost. So let's go ahead and do that using TM Pro. And all I'm really trying to do is basically create a method that we can subscribe to that static health on death event. We're going to obviously need some sort of score. So let's just call that current score and we'll create that as an int. And you know what? Let's just set that at 0 to start. And we're going to need a private TM Pro text. So TMP underscore text. We'll just call it our score text. And in awake, let's go ahead and get that. So we can just go ahead and int awake directly because we've got it attached to our score game object. We can go ahead and say score text is equal to get component TMP text. And what do we want to do every single time an enemy dies? Well, let's create a private void enemy destroyed method. And here we want to increase our current score by 1. So I'll just use the ++ syntax. And then we want to update our text. So how do we do that? We go into score text.text. And then we can just change it to current score to string. And then the only thing I'm going to kind of do is a little bit of an addition is I'm going to use this D3 overload because I want to make sure I'm always using a minimum of at least 3 digits in my UI. A little bit of a bonus there, but totally optional. And what do we want to do? Well, let's go ahead and plug in to that health on death event in on enable. And we'll go ahead and create an on disable as well. So going into health dot, I believe it's called on death. There we go. And we want to subscribe our enemy destroyed. And let's unsubscribe to it as well. Now, a little bit of a gotcha. We also are passing through that health component. So on our enemy destroyed, what do we need to do? We just want to go into our health and pass through our sender. We'll just call that little health component as sender, which even though we're not using it directly in this course, you can actually see the power of that here. If you had an enemy that was worth 2 points, you can go ahead and use that here. If you had an enemy that was worth 1 point or 3 points, you can actually update your score correctly. So let's head back into Unity and see if we got that rigged up correctly. Alrighty, I don't think we need to do anything in the inspector, so we'll hit the play button. And there you go. I'm gonna go ahead and untoggle my audio just so you can hear me okay. But every single time we have a slime dying, we are properly updating our score text in the top right. And you know what? I think that's all coming together quite nicely. Respawn event, just to kind of give our game a full loop so we can respawn right here in the middle. So well done on this lecture. Let's get those things set up on the next one. And when you're ready, I'll see you there. Let's set it up so that when our player dies, we properly respawn in this nice little safe area and continue to play as normal. Let's dive in. So in our assets and in our sprites folder, I believe it's in our environment folder, I have this nice little spawn zone sprite that I'm just going to go ahead and drag into my scene. I'm going to drag it up just to get it aligned properly. I think about there looks good. And what we can do is we can actually add a box collider 2D directly to it. And if we assign it to the friendly layer, then our player won't interact with it directly, but our enemies will, creating that nice little safe zone for us. So if I apply the friendly layer, and I just edit this box collider to be exactly around the sprite like it is as such, that way when I hit play, my player will not interact with it, but if our enemies were to actually try to interact with it as well, it would hit that box collider appropriately, creating that nice little safe zone for us, just like this. So what I'd like to do is in our UI canvas, I'd like to sort of fade in and out when our player dies and respawns accordingly. So in our UI canvas, the way that we can do that is if we actually just create a UI image, and then we just spread it all the way over the screen. So coming over here to our rect transform, I'm going to hold Alt and click this bottom right button to get it to spread and anchor properly all over the entirety of our UI canvas. Now the white is a bit ugly, so I'm just going to kind of choose somewhat of a dark blue. I think about there looks good. And with that set up, all we need to do is now in script, we can just modify this alpha transparency value accordingly and sort of give that fade in and out effect that we're looking for. I'm going to go ahead and rename this image to Fade Overlay. And let's go in and create a new custom C# script to set that up. So scripts, let's just put it in miscellaneous. And I'm just going to call this script Fade. Let's go ahead and open that up in VS Code. So what are we going to need right out of the gate? Let's create a serialized field for our player prefab so that we can properly respawn or basically reinstantiate that into our scene. So let's create a private game object and let's call it player prefab. What else are we going to need? We're going to need some sort of serialized field to basically let our Fade script know on where to respawn our player. So let's call it private transform and we can just call it our respawn point. And we have that nicely set up because we can actually just use that respawn sprite that we just created. Now I'm going to attach this directly to that image overlay that we just created. So let's go ahead and grab that image component directly. To do that, we're going to need to import the using Unity Engine UI namespace so that we can use the Unity image component. And while I'm up here, let's also grab our Cinemachine namespace so that we can properly reassign what our Cinemachine camera is looking at when our player basically is destroyed inside of the scene. We're going to need to just reassign that value. So using Cinemachine. And let's go ahead and grab those two components. So private image, and I'll just call it our image. And let's go ahead and grab that on awake. So all we need to do is set image equal to get component image. And let's also grab the Cinemachine camera as well. So private Cinemachine virtual camera. And I'll just call it my virtual cam for short. Let's go ahead and grab that in awake as well. We know we only have one virtual camera in our scene. So let's go ahead and grab that in awake as well using find first object of type. So virtual cam equals find first object by type, I'm probably going to say find object of type for years and years to come because that's going to be a hard habit for me to break. So what are we looking for? The Cinemachine virtual camera. Very nice. So the best way I think we can do that is we can basically just go into this image and using a coroutine as appropriate, basically just fade that in and out when our player dies. So let's create a public function that we can use and plug into whenever our player dies from another class. So for now, let's just call that fade in, and we'll just go ahead and return public void fade in. There we go. Now, where do we want to call this? So if we go into our health class, We basically have it set up in a way that when either our player or our enemies die and get to 0 health, they're basically going to get destroyed. So I think a relatively decent, easy way to set this up is in our player controller specifically. We don't want to actually tap into our enemies at all because we don't really care if they die necessarily. But right here below fixed update, I think is an appropriate place to put it. Let's use the onDestroy built-in mono behavior method basically to just say, hey, when our player controller class or game object dies, we just want to fire this sort of fade in function that we're going to call from our fade class. And using this method, we can basically just plug in and say, hey, when our player controller dies, do something. So with that set up, because we're not doing this very often and we only need to do it when our player controller dies, we don't necessarily need to cache it above because we're only going to fire it once per mono behavior. So let's just call it fade and let's just go ahead and find it here directly. Let's do find first object by type just like we did. We'll look for the fade class in our scene since we're not doing it very often, and we can just go into fade and basically call fade in. That way we have that properly rigged up when our player controller specifically dies, but we don't really care about when the enemies die. So heading back into our fade class, let's go ahead and rig up the additional logic to get that fading in and out appropriately using a coroutine. So we're going to have some sort of fade in, and we're also going to have a private void fade out. Now you could of course create these two separately, but I think a little bit more of a majestic sort of way to do it would be to just have one fade in coroutine kind of function that we can create, and then we can just call them directly in fade in and fade out appropriate as we need it. So let's get that set up. Let's create a private IE enumerator, and we'll just call it our fade routine. And all we need to do is take in a float as a parameter for a target alpha, and then we can pass that through as a parameter for both our fade in and fade out respectively. Now there's a few different ways to do this. I think the most straightforward way to do it is with a while loop. So what do we need to do? We've kind of faded things in and out before, so I'm not going to spend too much time breaking this down, but let's take it one step at a time. We're going to need a float elapsed time, and we're just going to go ahead and set that to 0 to start. But then we want to increment that by some kind of value by time.delta time while we're in our while loop. So let's create a start value as well. Start value is going to be equal to our image.color.a to return that float value of our current alpha value in our image. And instead of just checking while true, let's just check that our elapsed time is equal to some sort of time that we can set as a serialized field up top in case we want to modify it. So let's create one more serialized field as a private float, and we'll just call it fade time. I think something around 1.5 seconds will be good for me. Scrolling back down to our fade routine, while elapsed time is less than our fade time, then we want to go ahead and execute this while loop. What do we want to do in this while loop? Well, let's add to our elapsed time by using plus equals time.delta time. Now this next part is a little bit tricky. We basically just want to lerp it from point A to point B. So we can do that using float new alpha. We can go ahead and set that as that value. And what do we want to do? We want to lerp it using mathf.lerp. And what does that take in? That's going to first over here take in a start value on where we're beginning from. Well, that's easy enough. We have our start value. And what do we need next? We need a target value. Well, perfect. We set that up and passed that through as a parameter. So let's go ahead and use our target alpha for where we're trying to go to. And then last but not least, we want to make sure we're properly doing it over the time frame that we've set with our fade time. So the way we do that is with elapsed time divided by our fade time. That way it'll fade over the course of our fade time. Next up, we want to actually use this new alpha float and then set it directly as the alpha value inside of our image. So image.color, and I really wish you could say .color.a is equal to new alpha, but oh so sad. I've never been able to get that to work, so all you actually have to do is go in and set the whole color as a whole. So image.color equals new color. And then all we want to do is just go into each individual RGB A value, leave it the same, and then modify the A value. So what we have to do is go into image.color.R value, and then we want to do the same for the G values as well as the B values as well. So I'm going to go ahead and copy paste this a couple times. Now we just need to change this to the RGB values. So R, B, and G values. And then the last one, we actually do want it to be that new alpha value. Hey there, Steven from the future. Did you catch myself giving myself that little bit of a tongue twister? I definitely flip-flopped the B and the G values. You can definitely fix those yourself. It's definitely supposed to be RGB in that order and not RBG as I just did. But it'll actually work out relatively well moving forward. I'll make sure to get that adjusted or fixed shortly. We don't need to return anything when our while loop is complete, so we'll just go ahead and yield return null. And then after that is done, because this is a float value and sometimes it can be just a little bit off, all I'm going to do is actually just set my image.color to be the exact value that I want it to be. So what do I mean by that? I'm just going to take this entire line, copy it here, paste it here, and instead of plugging in our new alpha, I'm just going to actually set it to be our target alpha to make sure it's exactly 1 or 0, since sometimes lerping can be slightly inaccurate using time.delta time inside of a coroutine depending on your frame rate. Great, and that's all we need to do to properly set up our fade routine. So let's go ahead and call this in fade in and fade out appropriately. And then passing through my target alpha, I want to change that to 1 to be a nice solid black. Let's go ahead and try that out for now just to see what it looks like, and then we'll come back and finish it up in a moment. So in our hierarchy, fade overlay, let's go ahead and attach our fade class. And then here on our respawn point, I've got my spawn zone. I can just go ahead and drag that in here directly. And I'm also just going to keep organized and drag my spawn zone directly into my environment game object in my hierarchy. In my prefabs folder, let's go ahead and finally make our player a prefab. So dragging that into my prefabs folder. And then I can come back to my fade overlay and drag my player prefab directly into my serialized field. Okay, let's go ahead and see how that looks. I think I've got 3 health to start. I might actually have 5. I can't remember. So 1, 2, and 3. There we go. We die. Great. And we properly fade out. Nice. Looking good. And with that, I'll introduce us to this lecture's challenge, which is going to be properly fade back in and respawn our player after a nice short delay that looks and feels good to you. Go ahead and try to rig that up on your own. I don't think you need too much direction or too many hints. I believe in you. Pause the video, give it your best shot, and I'll see you back here in a few moments and we'll go through my solution together. Alright, welcome back. Now, there's a couple different ways to do this with some nice asynchronous logic. So the way that I'm actually going to do this is change my fade in to a coroutine itself to give us some nice asynchronous logic to work with. So private IE enumerator. This way, using a coroutine, you can actually yield return a coroutine directly. So this way, it'll actually wait until this coroutine is done before doing anything else. In other words, I can go ahead and call a respawn function right here before I fade back in. So start coroutine, fade routine, and then we just want to fade back in, so basically setting it to that 0 value. And then right here, I want to respawn. So let's go ahead and create that respawn method. All we need to do for that, private void, respawn. And all we need to do is reinstantiate our player. So let's go ahead and set player prefab to be reinstantiated at our respawn point. Dot position, and then we don't need any sort of specific rotation, so quaternion.identity will do the trick just fine. Then we just need to make sure we reassign our virtual camera dot follow property back to that player dot transform. So let's make sure we go ahead and cache this reference of our new instantiated player. Let's just call it transform. We'll just call it player. And then we can just set our follow property in our virtual camera equal to player. So a couple different ways that you could do this. You could create this as a game object and then say player.transform, or you can just go ahead and reinstantiate it as a transform directly with at the very end of our instantiation, just say dot transform. Both ways are totally acceptable. And then scrolling back up, there's a couple different ways to do this. We might have a little bit of an issue starting a coroutine using onDestroy from our player controller. So you know what, let's actually create a public void function, and we'll just call it fade in and out, and this is what we're actually going to call directly from our player controller. Once we're actually back inside of our fade routine, now that our player controller will be destroyed, we can go ahead and start this coroutine chain. So start coroutine, fade in. Inside of this coroutine, we can just go ahead and change this to private. We can delete our fade out method. We don't need that anymore. You could have totally set it up with a fade in and out method separately. That would have been totally appropriate. Inside here, we just want to call respawn. Back in our player controller, in our onDestroy method, let's rename the function we want to call to fade.fade in and out. Alright, let's go ahead and give both of those a save, make sure that's chained up correctly, head back into Unity and give it a try. Alrighty, let's see what this looks like. So 1, 2, and 3, we die, we fade out, that's looking good, and hey, there you go, we fade back in nice and quick, and we're all set to go. The camera is re-following our player as intended, and we've got a nice full game loop letting us infinitely destroy these slimes. Wow, that was actually impressive. I think I died in like the exact same spot. Look at me go. Now we do have one little bug. If we hit the stop button while the game is still playing, we'll sometimes get this null reference error on our onDestroy. So silly me, let's just go ahead and do a quick little null reference check to make sure that while we're in the editor, we're not getting that null reference exception. So fade, ? Dot fade in and out, and we should all be set to go. Well done on this lecture. We're nearing the end. When you're ready for the next one, I'll see you there. Let's rig up the audio manager in a way so that if we kill a few different enemies or more in quick succession, we'll get this mega kill sort of sound. Let's dive in. So the way that we can do this is actually introducing some custom logic directly into our audio manager. So before we do that, let's just actually rig up our audio manager scriptable object. So let's go into our sounds SO. I'm going to right click create, and we'll go ahead and create what I believe is our last one. And I'll just go ahead and call this mega kill. I'll rig up my clip with my mega kill sound. Mega kill. Yes, that sounds pretty good. Made that myself, not half bad. I think we can go ahead and leave everything else as is for now. And let's just go ahead and rig that up in our sound collection SO. So scrolling down here, let's just go ahead and open that up, and I think we need to plug that in manually. So let's create a new public sound SO array, and we'll just call it mega kill. Save that, head back into Unity. And right here at the bottom, let's just go ahead and rig that up. So plus, search for mega kill, and there we go. All rigged up in our audio manager in Unity, let's go ahead and rig that up now in the script itself. So opening up our audio manager. First and foremost, I'm just going to go ahead and in my SFX region, I'll just go ahead and create that. So I'll just make this a private void. We're just going to call it directly in the audio manager with some custom SFX logic. So I'll just call it audio manager just because it's in that class to follow our similar naming convention. And we'll go ahead and call it mega kill. All we want to do is just like above, we want to play random sound, go into our sounds collection, and play mega kill. Alright, with that rigged up, let's go ahead and close these regions down here. This music reason, don't need that. And let's go ahead and create one more region for organization. And I'm just going to call this one custom SFX logic. That way we can throw a couple different methods down here below. So how do we want to do this? We basically need some way to take in how many deaths we get per frame. Specifically, I'm just going to actually check it within one frame itself using a coroutine. And the way that I'm going to do that is basically add and remove things to a list within one single frame and just check, if we've killed more than 3 enemies within that frame, then we want to play the mega kill sound. Else, we don't really need to do anything. So let's go ahead and create that list. We'll just take in a list of the health class. That way we can basically check how many enemies have died using that onDeath event. So private list, I'll just call it death list, and we'll just create a new list to begin with. So new list, health. Very nice. Let's also cache a coroutine just to make sure we're only using one at a time per frame. So coroutine, death routine. And let's go ahead and create that method. So we'll just call it private void handle death. We'll want to take in our health component as a parameter. And then we'll just want to check to make sure that we're actually just checking to make sure it's an enemy. So if our player somehow dies in the same frame that we're killing 2 enemies, we want to make sure it's not including that one. So let's just create a simple little bool. We'll call it isEnemy. And we'll just actually check directly on the health class if it's an enemy. And the way that we can do that is we can go into inHealth, get component, enemy. That way this will return that true value if it has the enemy component attached to this health component. I think that's a nice way to do it. We're not doing it too often. I think this is relatively efficient. And then we can check if isEnemy is true, then we just want to add to our death list. So deathlist.add, and then we can just add in our health class that we passed through as a parameter. Next up, we basically want to fire a coroutine. So let's go ahead and start that. We'll call it private IE enumerator, and we'll call it the death window routine, where we can check within one frame. So how do we do that? We yield return null. That'll give us a nice one frame window to check all of this logic. And then let's create an integer called mega kill amount. You could probably do this as a serialized field, but for simplicity, I just want to make it so that if we kill 3 or more within this frame, then we fire that mega kill audio. So int mega kill amount equals 3, and then we just want to check that if death list count is greater than or equal to our mega kill amount, then we want to fire that audio. So audio manager underscore mega kill, and we can fire that method. Nice. Now I do also want to fire our on death little splatter effect, so I'll go ahead and do that as well. Now we are getting a little compilation error, and that's because this method here, if we check this directly, we're passing through this health class. Now, you could probably do this in a couple different ways. I'm just going to actually overload this method. So I'm going to copy and paste this entire method, and then I'm actually just going to delete this parameter. That way we can overload this method and we can call it in 2 different ways. We can either pass through the health class as needed, or below we can actually just do it without it entirely. And C# is smart enough to know which one it wants to call. So with that created, I think if we scroll down here, we're no longer getting that compilation error. Very nice. Below, let's clear the death list because we only want it to basically keep that list entirely for this specific frame. So deathlist.clear, and let's go ahead and clear the coroutine as well. So death routine equals null. Now, just for clarity, I usually name my coroutines coroutine, so I'm actually just going to rename this to underscore death coroutine. I like to name my coroutines coroutine and then my actual coroutine method just naming it in this routine, but that's entirely optional, just as a nice naming convention that I like to use. Next up, in our handle death method, let's just call that coroutine. So if death coroutine equals null, then let's just go ahead and start that coroutine. So start coroutine, death window routine, and let's just cache that to the death routine. So death coroutine equals start coroutine death window routine. Woo, little bit of a tongue twister. And we're almost set to go. We just want to make sure that at the very tippy top of our audio manager, we're actually subscribing not to health on death, but we actually want to subscribe and unsubscribe. So I'm going to double click and then just press Control D to highlight both at the same time. And we want to subscribe to handle death. That way, in our custom logic methods, it'll handle all of that logic for us as needed. Nice. Let's go ahead and back into Unity and see how that sounds. All right, for this, I'm going to go ahead and need to enable my sound, and I'm just going to give this a minute until I have at least 3 enemies bunched up. Let's actually just kill one to make sure our splatter still works while I'm not talking. Yep, that still sounds good. And then right about here, where all 3 bunched up, I'm just going to use a grenade. And there you go, we've got a nice little mega kill. Let's try again. Oh, we only got 2. Right here. Nice, there we go. Hey, you know what? That sounds and looks great. All right, well done on this lecture. When you're ready to move forward, I'll see you on the next one. In this lecture, let's make sure we add a little bit of max velocity to our negative y value to make sure that we don't accelerate infinitely as we just continue to fall. Let's dive in. Now to do that, I think we just need to add a couple different lines of logic to our player controller directly. So let's go ahead and open that up in VS Code. And to do that, let's go ahead and create a serialized float for that max fall speed. So I'm just going to go ahead and duplicate this because we know we're going to want a private float. And I will just go ahead and change this to max fall speed velocity. And I'm going to change that to something like -20f to start, and we can go ahead and play around with that back in Unity. So let's see, where do we want to put this? In a fixed update, we're actually calling this extra gravity speed. Let's go ahead and see if there's somewhere where we can put it inside here. Now let's just kind of go through this together and actually see how fast we're falling when we fall. So let's add a little bit of a debug.log, and debug.log our rigid body .velocity .y value to kind of see where we're at in Unity. So let's head back into Unity and test that out. And to give us a little bit of a leeway, I'm just going to drag my player up somewhere to kind of give us a nice little fall. I think about there should be, right? Let's click play, open up our console. I'm going to mute my game sound. And while falling, yep, there we go. I hit about -37. Let's try that one more time to see what it looks like. So right about there, I don't want to continually accelerate. I think even actually to really drive this point home, if I was to drag my player outside of the scene, even though it's going to break my Cinemachine camera, we're going to see that it's just going to infinitely accelerate down to light speed sort of speeds. So I think somewhere around -20, -25 should be about right. So how do we want to handle setting that up? Well, if we head back into our extra gravity method, we can add an additional if statement and basically just check if our rigid body dot velocity dot y is less than our max fall speed velocity. Well, then what do we want to do? We want to set our rigid body velocity equal to a new vector too. Now you can't change the y value directly, so all we need to do is just change our rigid body velocity to be equal to our rigid body velocity dot x, because we don't actually want to change that. So rigid body dot velocity dot x value, don't need to change that. And then we just need to change this to our max fall speed velocity. And I think that's all we need to do. But let's go ahead and just check this debug.log to make sure that it's working properly. Instead of putting it in the if statement, I'm just going to put it at the bottom of our extra gravity method just to make sure it fires every fixed update frame. So, yep, looks good. Let's go try that out and test it out back in Unity. All right, if we just kind of look over here in our scene view, it's not going to work on our camera directly. There we go. As soon as it gets to -20, it continues to fall and it stays at -20, but I can still move to the left and right accordingly. Now, I think that's just a tad slow, so if I change that to something like -25, apply that to the prefab, and let's just go ahead and shift that back in our game scene, back to where I can actually fall, and down, I think around -25. Yep, that looks and feels about right. But our Cinemachine camera, I think, needs a little bit of adjusting. So if we go into our virtual camera directly, we can actually open up this transitions. I think it might be in body. Yep, there we go. We can just kind of adjust some of the damping we have here. So I'm not going to think about it too much. I just kind of want to shift my bias up, as well as kind of shift around my soft zone height. So maybe to something around there. That way I think it'll kind of fall and give us the effect that I'm kind of looking for. So when I fall down here, yeah, I think that's about right. A little bit of a leeway, and I actually do kind of like that sort of buffer on the Y side so I can actually look a little bit more up than I can down. I think that's pretty normal for side scrollers. And I do think that looks pretty good. But I do think, if I'm not mistaken, I do have one little tiny bug I'd like to fix. So let's go ahead and look at that closely again with my game view blown up. And go ahead and take a look at my gun. When I shift down, you can see my gun just vibrate just a little bit when I'm falling too fast. Now that's because my camera is trying to play a little bit of a catch-up. So all we need to do to adjust that, click my camera, come down over here, and all I want to do is change my blend update method to fixed update. And I think that should adjust it. We might actually want to change my update method back to smart update. I think we changed that quite a while ago. But let's go ahead and see if this works. So shifting down, taking a look at my gun. Okay, there we go. So I didn't actually see that shift. I'm going to test it one more time just for a little bit of sanity on my end. But it looks like my gun, there we go. It's not actually shaking and everything seems to be working as intended. And I've got that nice max fall speed velocity. And I think everything is looking and feeling great. Now, that's all for now. If anything additional is added, it'll be a little bit of a bonus. But for now, I'm pretty satisfied with everything. If you'd like, you can go ahead and add some additional pipes, disco balls, and enemies and platforms all around your level to your heart's content. But for now, I'm pretty satisfied. I'm just going to go ahead and delete this debug.log, head back into Unity, and I think we're set to go. All right, well done on this lecture implementing that max fall speed velocity. I am super impressed with everything we have set up so far, and everything is starting to look and feel really good, clean, and professional. All right, well done on this lecture. When you're ready to move forward, I'll see you on the next one.